Hello everybody, I'm Santhosh pursuing BE Aeronautical Engineering and today I'm going to take a seminar on magnetic particle testing. Before going into the topic, we must know what is magnetism. Magnetism is the ability of matter to attract other matter to itself. Objects that possess the property of magnetism are said to be magnetic or magnetized, and the magnetic lines of force can be found in and around the objects. A magnetic pole is a point where the magnetic line of force exits or enters a material. Seeing the below images, you can know how the magnetic field lines are moving around the bar. How does magnetic particle inspection work? A ferromagnetic test specimen is magnetized with a strong magnetic field created by a magnet or special equipment. If the specimen has discontinuity, the discontinuity will interrupt the magnetic field flowing through the specimen and leakages will occur. How does magnetic particle inspection work? Finally, mild iron particles coated with a dye pigment are applied to the test specimen. These particles are attracted to leakage fields and will cluster to form an indication directly over the discontinuity. This indication can be visually detected under proper lighting condition. We'll see the basic procedures. Pre-cleaning. When inspecting a test part with a magnetic particle method is essential for particles to have unimpeded path for migration to both strong and weak leakage fields alike. The path surfaces should be clean and dry before inspection. Magnetic field. The required magnetic field can be introduced into a component in a number of different ways. First, using a permanent magnet or an electromagnet that contacts the test piece, following an electrical current through the specimen, following an electrical current through a coil of wire around the part or through a central conductor running near a part. Direction of magnetic field. Two general types of magnetic fields may be established within the specimen. The type of magnetic field established is determined by method used to magnetize the specimen. A longitudinal magnetic field has magnetic field lines of force that run parallel to long axis of the part. A circular magnetic field has magnetic field lines of force that run circumferentially around the perimeter of the part, producing longitudinal magnetic field using a coil. A longitudinal magnetic field is usually established by placing a part near the inside or the coil's annulus. This produces magnetic lines of force that are parallel to long axis of just the part, producing a longitudinal field using permanent or electromagnetic magnets. Permanent magnets and electromagnetic yokes are also often used to produce longitudinal magnetic field. The magnetic lines of force run from one pole to other, and the poles are positioned such that any flaws present run normal to these lines of force. Circular magnetic fields. Circular magnetic fields are produced by passing current through the part or by placing the part in a strong circular magnetic field. A headshot on a wet horizontal test unit and the use of prods are several common methods of injecting current in a part to produce a circular magnetic field. Application of magnetic media. MPI can be performed using either dry particles or particles suspended in a liquid. With the dry method, the particles are lightly dusted onto the surface. With the wet method, the part is flooded with a solution carrying the particles. Dry magnet particles. Magnetic particles come in variety of colors. A color that produces a high level of contrast against the background should be used. This is a crankshaft which has a crack on the noob hole. And that's it. Thank you for